Okay, we're going to look at some gas law problems. I'm using your worksheet or your homework as a reference. It's the mixed gas law calculations, very tiny print, half a page. We're going to be looking at number 5 as an example. And so when I read it, and I really would like you to read it on your piece of paper while I'm doing it up here, because as you know, you can't see this at all. So, mixed gas law calculations number 5 states, a glass sphere is filled to full volume with gas. The pressure of gas inside the sphere is 30 atmospheres. Okay, so pressure is 30 atmospheres. And the temperature is 25 degrees Celsius. Okay, got another temperature. The sphere is taken outside on a cold day. The temperature of the gas decreases to 10 degrees Celsius. Temperature decreases to 10 Celsius. What is the new pressure? I have to find a new pressure, and pressure is measured in atmospheres in this problem, so I'm going to find a new atmosphere and assume that the volume is constant. Okay, so I synthesized the information here. We got pressure 30, temperature 25, temperature decreases to 10 degrees Celsius, and what is the new pressure? There's one thing I need to change in this before I get going, and that is whenever I work with temperature on gas laws, Celsius isn't going to cut it. I need to work with Kelvin, the standard. So I'm going to come over here and I'm going to see that temperature is 25.0 degrees Celsius. In order to change it to Kelvin, I'm always going to add 273. Okay. And when I do that, I see that it's 298 Kelvin. Okay, so I'm going to use that. And then down here it decreases to 10. I'm going to say 10 plus 273 is 283 Kelvin. Once I make those changes, I can go ahead and move on with the problem. I see I'm going to use the combined gas law because it just works for every problem. It's a little bit extra work, but I don't have to memorize more than one equation. So when I look at my PV over T equals PV over T, that's great, except I do need to make sure that I indicate that this is the initial. This is the first PV over T, and after I do the experiment, this is the second PV and T that I come up with. So if we look at the top here, I need pressure. So I look and I see pressure is 30 atmospheres. So I'm going to go ahead and put 30.0. And then it says volume. Now volume I don't see anywhere around here, so I'm just going to put a big V. I'm going to put it over the initial temperature, and when I start this experiment, I have 25.0 degrees Celsius, or 298 Kelvin. I'm going to set this equal to the new pressure, and it says new pressure question mark, so I'm going to put P there. I'm going to multiply it by the volume. When I look up here, I don't really see volume, so I'm going to go ahead and put a V there. And then I'm going to divide it by temperature, and when I look, I see my original temperature was 298. My final temperature is 283. So I'm going to do 283 there. Okay. Then I notice that I've got P, that's fine, but I've got B, 2 of them, so I'm just going to cross them out. Okay, and that's what I mean by using the combined gas law, no matter what problem you're solving. Okay. Then I'm going to go ahead and, let's see, I'm going to have to do this butterfly thing, cross multiply, whatever you call it. Okay, but that's going to be one side, and then this is going to be another side. So here I have 298 times P, so 298 P equals, and here I have 283 times 30, and that's the volume I crossed out. So 283 times 30.0. When I do this side, I get 8640. And when I do this side, it's exactly the same. 298p divide by 298
divide by 298, and I get P that crosses out. P equals whatever this is, which is 28.5. And then I go back here for units. I want to know pressure, and pressure is measured in atmospheres in this problem. So 28.5 atmospheres is the final pressure.